welcome to CryptIst, and for our foreign guests, welcome to Istanbul. I hope everyone has been having fun, enjoying the city, although today is not the best day weather-wise, but still. So we have the panel with our 4 esteemed guests. I will be introducing them one by one. Maybe you can come in. We have Georg Visa, software engineer at Powder. Then we have Craig Johnson, DevRel at Avio, Connor O'Hara, Rollkit software engineer at Celestia, and we have Militia, did I pronounce correctly? Militia Woollage, developer education lead at ZKIM. So we will be talking about ZK developer experience and tooling, and also education. Welcome, everyone.
Thank you.
Hi. Round of applause for our panelists. So maybe first, can you guys one by one introduce yourselves and maybe your projects and how your project relates to ZK?
Sure. Is this working? Yeah. I'm Georg. I'm working with Powder, and Powder is building tooling to build ZKVMs. So very specific user set, but people that are building ZKVMs, they will have like a programming language, makes it very easy in a few hundred lines of code to specify a virtual machine. And that's what we do.
Hey guys, thanks for having me. I'm Craig. I do developer relations at Avio. Avio is a layer 1 blockchain focused on ZK and privacy. We're building a whole suite of tools to ideally make the experience of building ZK apps super easy and developer friendly. So that's everything from a DSL to ways to deploy apps, et cetera, et cetera. So I'm sure we'll dive into it more later. Thanks.
I'm Connor. I'm a software engineer at Celestia Labs. Celestia is a layer 1 blockchain, which is massively scalable, and it hosts its own rollups in addition to being able to support Ethereum L2s.
Assalamu alaikum. My name is Militia Woollage. I'm a developer education lead at ZKM, or better known maybe as ZKVMs.
Great, thanks everyone. So for the sake of time, I will skip the intro part a bit and dive into the topic. So maybe first start with what brought you to ZK space, and what do you think does it take to bring the next wave of developers to ZK? Maybe this time other way around?
Yeah, so I think I arrived into ZK space through cryptography. So I went through education as a software engineer, then through the master's grade, and then I had my final work as a cryptography part. 2 years ago, I think, I went into some lectures, and I think there was some kind of meetup, and then there were PhDs in math, and then showing ZKs, and I thought it's magic. So that's my story.
I first heard about ZK from Zcash when that launched, and I thought it was pretty amazing that somebody fixed the bug in Bitcoin called transparency, and followed it ever since, and it's really cool, and I love it.
Yeah, I got to, I guess, similar to you, I studied computer science, and I was never super into cryptography while I was a student, but as I got deeper and deeper into Web3 and heard more about projects like Zcash and Snarks, and just kind of slowly fell down the rabbit hole until I decided to get into ZK full time.
Yeah, I got interested in ZK because similar to you guys, like that combining privacy and audibility is really cool, because oftentimes they're seen as like opposites. To bring the next wave of developers, I think it's important. I feel like a lot of people in ZK right now, they really like to be deep in the subject. To bring the next people, it's probably good to improve tooling and just make it easier for people to get started without having to know all the details about how it works.
Yeah, also to follow up maybe on that topic, I'm also not a ZK native. Let's say I'm working on blockchains and mostly Solidity tooling. but I'm not a ZK native. So what would you say for a person like me, or maybe even a newcomer, are the main challenges for getting into development? So feel free to pick this up.
Yeah, I think there's a lot of challenges to getting into ZK development right now, especially coming from, if you're not coming from an advanced math background or you haven't really studied cryptography, those are certainly barriers to entry. And I think one of the most exciting developments in this space right now are the level of abstraction is growing, right? And we're starting to abstract away details like elliptic curve cryptography. You don't need to know what prime you're using, right, necessarily anymore to actually use ZK and build an app with it. And so I agree with your point. Better tooling, better abstractions, and really just hiding the messy details from your average developer is probably what's going to take to onboard, the next 10x number of devs into ZK.
I had a friend who looked into a ZK DSL, and he was like, it's crazy. If you have number 6 and you divide by 3, you get 2. If you divide by 5, you get some random number. So I think that kind of showcases like the challenges you face if you get started.
Any other main challenges you can think of?
To get into ZKs?
Yes.
As a developer. So I faced those challenges myself, I think. But first of all, when you take a look at basically any ZK meetup, usually it gets into maths, really just like diving into formulas, and it looks scary for a reason, because there's like layers and layers of cryptography, elliptic curves, phi protocol, many things. And so I think basically that layer of education that software engineers lack, or developers that do not have standard education about that, it's scary because there's a lot of maths. Mm-hmm. So that's it.
The tooling is in a much better place than it used to be. There's now a number of pretty good DSLs which you can use to write a circuit, and there's also now some ZKVMs that are getting really good, so you don't even have to even know what a circuit is. But still, just understanding what a zero-knowledge proof even is seems to escape a lot of the people who might be interested in working with them. So I think just teaching people about the possibility and the whole you can prove a statement without revealing all of its inputs, more people should know about that. More people should know at a very high level what it even is.
Yeah, I think that's a great point, right? Not just tooling. If the tooling exists and it's perfect, that's great. But if we're not educating people and building awareness of the potentials and how this technology works, it's pretty hard to get any usage or adoption of the tooling.
Yeah, maybe dive a bit deeper on what you said about abstraction. I want to go inside that a bit. So for example, I'm thinking about the elliptic curve cryptography and TLS and HTTPS that we have been able to abstract away from the user, right? They don't have what's going on. They don't need to know. They just maybe need to see the check mark or the security sign. Do you guys have any examples that we can think of would be useful as an examples in ZK that we can abstract away? Any ideas?
Sure. So, for example, you have validity proofs used in layer 1 blockchains. I think that's the future. I think every chain should have validity proofs for itself. Mina is the only one that really I can think of that does. You can just verify the entire chain in one proof all the way from Genesis to the chain head. And that's quite a lot better than if you're just trusting an RPC service, which is the way that most users access blockchain apps. And a lot of people say, oh, users don't care about that. But your mom still probably looks at that little padlock in the address bar when she goes to her online banking, and if it was red with an X through it, she probably wouldn't enter her password. We just need to display to the user that everything is valid and everything is legit, and then maybe someday people will not accept anything less. We'll train them to demand more security.
Yeah, maybe also on that, do they really need to know, for example, what a ZK proof is? Because even explaining the concept is quite difficult. How can we abstract away that from them?
Yeah, I think this is an interesting one because all of Web3 has this problem, right? Wallets have the same exact issue, and what is a very popular topic these days is account abstraction. How do you get people to use crypto without knowing that they're using crypto, right? And I think very much the direction that we need to move is the same with ZK, right? How can you build zero knowledge into underlying technology so that people are using it without necessarily even knowing that that's the tech that's powering whatever service that they might be using. And I think if I had to guess, at least in certain jurisdictions in the world, consumers at the consumer level don't necessarily care about privacy. And this is kind of what you said, right? Security is not the top, their top concern. They might care about fun or earning money or whatever instead, right? Entertainment, etc. And I think you'll see adoption of ZK really at the enterprise level first. At least, for example, in the US, where privacy is not a huge consumer concern, unless the government makes you do it.
Mm-hmm. Yeah, I think that as time passes by, we'll have more ZKs and we will not even pay attention maybe to it, like general internet user does not pay attention, for example, how is the page encrypted and their connection, so they don't know about elliptic curve digital signature, but they still use it. As you said, they see the padlock. So I think that as time passes by, we'll have more usage of ZKs then we're going to get into the ZK proofs.
Mm-hmm. Yeah, I only agree. So I think for the end user, it's very hard to communicate, and probably there's not much more to do than tell them it's okay, and this is what you should look out for.
Mm-hmm. Maybe going with the use cases and the users, what use cases are you most excited about in ZK applications of the ZK proofs? Maybe ZKVMs?
For sure, ZKVMs or ZKVMs in general are great. I guess they're mostly about developer experience, and it's like a way. The good thing is there's two approaches to building zero knowledge proofs. There's ZKVMs and then there's circuits, and circuits are usually much more efficient and customized, but you can build specialized ZKVMs that have coprocessors that are very optimized on some task, like hashing, and I think that's a good way to onboard more developers. In terms of end user applications, I think anything for me that combines privacy and auditability is a great use case. It's really exciting to see people working on private smart contract execution. So it's sort of combining the ideas of Zcash and Ethereum. I think that's really great and opens a lot of possibilities.
Yeah, I think you made an interesting point there, right? That there are very real trade-offs between a ZKVM, which typically chooses a specific proof system and kind of implements its proving in a specific way, and it might be very difficult to change. The ZK research moves so fast that every couple of months there is a new proving system or an improvement in one of them, and so it's very much like a race. And so once you have to choose one, it can be difficult to switch. And so it's interesting that there's lower level options to, you can choose which proving system you're using, you can choose what prime number you're using to do your elliptic curves, right? And so you do trade-off performance for usability. And so it really comes down to what is your goal, right? If your goal is to increase the number of developers, then the ZKVMs are really the way to go for that, because the developer experience of using these lower level DSLs is not necessarily ideal, although it is pretty good. But if your option, if you're just trying to maximize performance for, say, a consumer-grade app that can scale to millions or billions of users, it's almost like inlining assembly in your Solidity contract, right? You're removing some safety for pure performance, and that's a very conscious decision that you need to make depending on your specific use cases.
Mm-hmm. Yeah, go ahead, please.
I wanted also to say that I'm excited about ZKVMs because you as a developer, you don't have to know much about ZKs in order to use it. So pretty much you can write and use your smart contracts with Solidity. You can use Rust, and you don't have to know about ZKs. So ZKVMs are basically providing proof and taking care of that for you. But also you can use traditional non-blockchain languages like Java and C, C++ without any hassle.
I want to take the thread on the trade-off side of things, especially performance and developer usability, but also want to just make my statement about one thing I'm excited about ZK is especially the password side of things. Like we don't even need to send an encrypted password to the server. Why we still haven't cracked the code of the authentication part of things in the ZK. I think there are like some applications of this in ZooPass. We will also experience it this week. That will be interesting to see that in action, I would say. But coming back to the trade-off part, in general, I think we can say there's a trade-off between the performance and the developer friendliness in the space, right? How do you guys, in your projects, maybe prioritize one over the other?
So I think I already talked a bit about that, like that I think that using ZKVMs and with specialized chips basically is a good solution in that trade-off. But one thing to note is that it's the cost model is very difficult. Like it's not easy for the end user to know what's actually costly when I'm doing a computation. So I think also maybe some profiling tools also need to be developed and enhanced for users to even know like what is the performance bottleneck right now.
How is it like estimated now? What is the heuristic to make the cost now? What do you guys, for example, do it?
Oh, I think we just manually check like what is taking the most computation steps. And it's fine for us to do, right? But it probably could be improved for the end user, I guess. Because it's very unintuitive. It's very different from the cost model you would have if you would write a Rust program for a different architecture.
Yeah, I guess Alio is a layer one that includes a ZKVM and a DSL. So I would say we're fairly opinionated, where we've chosen a proving system. However, I think the benefit of choosing to be opinionated is that the developer experience is quite nice, and it allows it to be high level. Because by choosing things for the developers, you abstract away those details. They don't have to worry about them. They don't need to know. Really, you don't need to know what elliptic curve cryptography is, right? To use our DSL Leo, it does look a bit like Rust or JavaScript, or ideally, right? Thinking about your use case, a developer who might not know anything about ZK. I want you to be able to jump in and just say, hey, this kind of looks like something I'm familiar with. Learn the new, data models that you might need to know, and get to building your app. Right? So really reducing that time from, hey, I have an idea that I could use ZK to, oh, I'm deploying an app on chain and I'm writing a front end for it, and we're live, right? We have users using it. I think that's like one of the largest goals of Alio today.
If you think that the next big thing is going to be programmable ZK-proof platforms, then certainly you want to trade off performance for that developer experience. But if it's just a few apps that end up getting adopted, like maybe there will be one killer payments app or one killer, scaling blockchain app, then you don't really care so much. You want to hand optimize your circuits and focus on performance to have the fastest proving time on those products and make it as good as possible. So it comes down to like, what are these computing platforms going to be what takes off, or will it be like specific things within those that we want to focus on?
Yeah, when we speak about trading, trade-off between developer experience and performance, so I would always choose developer experience. In the end, you need to have good performance as well, but if you don't have good developer experience, you will have no product. No one is going to develop anything.
I think I have one last point, and just looking at the history of computing and programming languages, right? If you look at like what's the most popular general purpose programming language today, and I could very confidently say it's probably Python or JavaScript. Very high level, not very performant in the grand. If you look at something like Rust or C++ or, God forbid, Fortran, right? And how were these languages enabled, and how was the adoption of that grown over time? And it's really via hardware optimization. The hardware's just gotten so good that you no longer need to like scramble and fight for every little bit and byte, right? And I think that's something that we'll see as more capital gets invested into the space, and you see things like ASICs and FPGA improvements. And there's lots of research teams and people working on these types of problems. But I'm excited to see how that might allow, as proving times drop and hashing and speed increases and blah blah blah. Every little bits and piece of the proving systems improves in speed. You might be able to focus more on developer experience as opposed to having to go above and beyond for performance. Mm-hmm.
Yeah, I think maybe we can say the ultimate scarce resource is the developers, right? Maybe optimized for developers, and the rest will be handled by the compiler devs and the deeper devs, let's say. So I think we are close to the end of our panel. There's so much more I would like to speak, actually, but our time is due. I would like to thank everyone once again for coming in. A round of applause for our panelists. And thank you.
Thanks.